Hello! Arthur here. Every day you are bombarded with space dust. There is estimated to be between 100,000 and 300,000 kilograms of material that falls to Earth from space each day. Most of this is less than 2 millimeters across, which is the minimum diameter a cosmic body must have to create a shooting star as it passes through the atmosphere. During an entire year, 40 million kilograms worth of matter falls to Earth. This may sound like a lot, but it is only 6 quintillions of Earth's total mass, the weight of 20 Saturn V rockets or 200 Statues of Liberty falls to Earth each year, but is still nothing compared to the Earth itself. Most of this mass is released in small amounts, scattered all around the world. But it doesn't take much mass falling to Earth in one go to cause some serious damage. Such an event is unlikely to happen anytime soon, but being prepared is always good. If it was discovered tomorrow that a deadly asteroid would hit Earth, how could we stop it, if at all? Before we discuss potential ways to prevent an asteroid strike, let's first define what an asteroid is and how they differ from comets and meteorites. Asteroids are small rocky objects that orbit the Sun. Comets, on the other hand, are small icy objects whose ice can vaporize in sunlight to form a trail of ice and gas that we see in the sky. And meteorites are small fragments of asteroids or comets, which are what you see when you see a shooting star. To be classed as an asteroid, a rocky body must have a diameter greater than a meter. Asteroids come in various sizes, and multiple factors such as density, diameter, speed, and angle of collision can affect how much damage is caused by an asteroid. The website Impact Earth can help with this. The average asteroid travels at a speed of 17 kilometers per second, which is around the same speed as Voyager 1, currently on a trajectory out of the solar system. If a train with this speed was built on Earth, you could travel from London to New York in little over 5 minutes. You may have seen this footage from Russia in 2013. On February 15th of that year, a 17-meter wide asteroid passed through the atmosphere, creating the fireball you see. The asteroid broke down before reaching the surface, but still broke windows and buildings and injured over 1,000 people. An asteroid with a diameter of 100 meters across would be enough to destroy a city, and can be best avoided by knowing when and where it would land, ensuring to evacuate beforehand. An asteroid with a diameter of a kilometre or two would be able to destroy a country not much bigger than the UK. An asteroid more than 10 kilometres across falling to Earth would be enough to wipe out all life on Earth. 10 kilometres sounds gargantuan, but here's a comparison. If the Earth was actually the size of a 30 centimetre globe, such an asteroid wouldn't be much bigger than your average peppercorn. If this peppercorn were to strike in central London, a fireball would be created and would be visible as far away as Oslo, Barcelona and Berlin. Glass windows would shatter as far away as Newfoundland, Canada in the west, to Baku, Azerbaijan in the east, to Niamey, Niger in the south. Wood frame buildings would also collapse as far away as Helsinki, Reykjavik and Tunis, and steel framed buildings in Edinburgh and Amsterdam would collapse. The final crater formed would have a diameter of 68.3 miles and a depth of 0.756 miles. And that's from a peppercorn striking a globe. It's serious business. We want to avoid it best we can. The first step in stopping the potentially deadly asteroid is to detect the asteroid. But detecting asteroids is not easy. The Chelyabinsk asteroid was an example of one we failed to spot beforehand. Detecting asteroids is so hard that only 5 of the 1,200 asteroids that have struck Earth since 1988 have been detected beforehand. The Atlas project, funded by NASA, plans to build a series of telescopes throughout the world to give NASA constant coverage of the night sky. The problem of detecting asteroids is that compared to the vastness of space, asteroids are tiny. Remember the peppercorn analogy? Well, now imagine that tiny people on this globe are trying to find peppercorns that are constantly in motion and are potentially miles away in a giant dark room with only one major light source, the sun. Now take into account that these peppercorns only reflect 15% of the light that hits them, and you've got an idea of the challenge. Asteroids must be detected using telescopes with wide fields of view, making observations over many days. Asteroids are best found when illuminated by the sun, which only happens when the sun is on opposite sides of the Earth to the asteroid, resulting in only a tiny percentage of the near-Earth asteroids being detected. Detecting the asteroid is only the first step, however. Then we will have to make constant measurements over many years in order to detect the asteroid and determine its trajectory. Despite all this difficulty, scientists believe that they have found all the potentially planet-killing asteroids, and that none of them will pass Earth anytime soon. However, for every planet killer we have detected, there are many more asteroids we haven't detected, which have the potential to destroy cities or countries. These are even harder to find since they're smaller than the proverbial peppercorn, and many asteroids we detect have become lost since discovery because of insufficient orbital observations. There are many potential methods for stopping an asteroid. Straight up destroying the asteroid is not the best idea, as it would likely be broken down into smaller pieces, and it's hard to predict where they would land and how much damage it would cause. A better method of prevention is to nudge the asteroid. The further an advanced detection takes place, the better, and the less we'll have to move it. One idea is to paint a side of the asteroid to alter the number of protons absorbed or reflected, and allow sunlight to change the asteroid's course. Another is to use the mutual gravitational attraction of the asteroid and rocket and prevent the two bodies coming together by using retro-rockets, and thus slowly tow the asteroid away from its trajectory towards Earth. In order to prevent collision, an asteroid would only have to be slowed down by about 1/10,000,000th of its normal speed. NASA's DART mission is launching in July of this year using a SpaceX Falcon 9 rocket, and will reach the Didymos binary asteroid system in September of next year. The Didymos system is made up of Didymos A, which is orbited by Didymos B, where DART will land. The mission's objectives are to redirect the course of an asteroid's moon. The spacecraft will impact the asteroid and test kinetic impactor technology in the process, in an attempt to deflect the asteroid off course. Another goal of this mission is to alter the rotation period of the asteroid's moon by around 73 seconds, observing the change from the ground. So, are we ready for asteroids? Well, in 2019, scientists concluded that destroying asteroids may be more difficult than previously thought, and it has been estimated that if a deadly asteroid were discovered tomorrow, we would need 20 years to build an impactor in order to reach the asteroid and prevent it from impacting Earth. However, many people believe we can prevent such a disaster. There is no agreement about this issue, and much of the technology is still in the early stages. For now, we'll just have to hope no asteroids come our way. Thanks for watching.